Hello everyone, I am Brandon Ordoñez from ECE41 and today I will be performing our experiment number 2 for our robotics laboratory, which is entitled Control of Stepper Motor. Hello everyone, so now let us begin with our experiment. So first, the objectives of this experiment are: this experiment will enable the student to control the direction of rotation of a stepper motor using H-bridge circuit, to control the speed of rotation of a stepper motor, to control the angular displacement of the stepper. The last objective is disregarded since we will no longer create a user interface for our Arduino program. So first, for part 1, create a program that will control the direction of the motor by sending the right sequence of pulse to the motor, sending the sequence of pulse to make the motor rotate clockwise, sending the sequence of pulse in reverse order to make the motor rotate counterclockwise, and stop sending pulse will cause the motor to stop. So this is the Arduino Sketch that we would use for controlling the direction of the stepper motor. We've included a character dir, which would be our input from our serial monitor. Next steps, this would determine the direction or the value that would be received by our stepper motor that would control its direction. And constant integer SPR, I have changed this to 200 so that the movement of the stepper motor would be faster. So next, these are some default configurations. So first, I have included a message that would appear at the serial monitor when we have uploaded the program to our Arduino Uno. So a message would appear saying that you can now control your stepper motor. Controls: A for clockwise rotation, B for counterclockwise rotation, and C in order to stop the motor. Next, for our main program here, so this would be our input dir. So if we would input A at our serial monitor, steps would be in negative value in order for us to get a clockwise direction for our stepper motor. A message would appear saying you entered dir, which is A for this case, and a message would appear saying that the step motor is now turning clockwise. Next, case B, this would be for our counterclockwise rotation of our stepper motor. A message would appear saying you entered and dir, which is B, and a message that says the step motor is now turning counterclockwise. Lastly, when we input C, the number of steps to be taken is 0, meaning that the stepper motor stops. A message would appear saying you entered and the direction dir, for this case C, and a message would appear saying that the step motor stops. So that is it for our part 1. Next, for our part 2, create a program that will control the speed of the motor by controlling the pulse frequency of the microcontroller. So this would be our Arduino Sketch for part 2 of our experiment. So I have the default variables used for this sketch are speed and SP, and constant integers SPR20. I no longer change this the value of SPR since we would be controlling the speed of our motor for this part. So initially, a message would appear saying you can now control the speed of your stepper motor, empty line. Note, for observable results, input with an interval of 100. So we would input numbers with a difference of 100 with an interval in order to observe the results quickly. And since if we would enter 10 or values lower than 100, it would take time for the stepper motor to rotate. And since the stepper motor reads value after every rotation, it is best to input a high value so that we would be able to change the value received by our stepper motor quickly. So speed, serial present, this would be the part wherein we would input our value at our serial monitor, and a message would appear saying you've set the speed to and the speed you've inputted, and an empty line for organization of data input. So next, part 3, create a program that will control the angular displacement of the motor by sending a number of steps in the microcontroller. So this would be our Arduino Sketch for part 3 of our experiment. There. So these have two variables used, steps and SPR is equal to 20. So for the void setup, I have included a message saying you can now tell your stepper motor the number of steps it should take. So we would input a value and the stepper motor would rotate on how much steps that was inputted from our serial monitor. So here, this would be the part wherein we would input and the Arduino Uno would read the value that has been inputted, and a message would appear saying number of steps entered and the number of steps that was entered in the serial monitor. So after that, we would go to fritzing in order to see the proposed breadboard circuit assembly for our experiment. So the circuit assembly for all the parts are the same. For all parts of the experiment are the same, since we would only change the Arduino Sketch uploaded to our Arduino. So first, we would use an integrated circuit, an L293D. And now let us proceed to the connections of the pins of our integrated circuit to other components of our circuit. So pin 1 would be connected to the positive terminal, positive 5 volts terminal. Pin 2 would be connected to pin 8 of our Arduino Uno. Pin 3 would be connected to coil 1 of our step motor. Pin 4 and pin 5 are connected to the ground terminal of our breadboard. Pin 6 would be connected to coil number 2 of our step motor. And pin 7 would be connected to pin 9 of our Arduino Uno. And pin 8 would be connected to the positive 5 volts terminal of our breadboard. Next, pin 9 would be connected to the positive terminal of our breadboard, 5 volts. Pin 10 would be connected to pin 10 of our Arduino Uno. Pin 11 would be connected to coil number 4 of our stepper motor. Pin 12 and pin 13 are connected to the ground terminal of our breadboard here. Pin 14 would be connected to coil number 3 of our stepper motor. Next, pin 15 would be connected to pin 11 of our Arduino Uno. And lastly, pin 16 is connected to the positive terminal of our breadboard. The 5 volts terminal of our Arduino Uno is connected to the positive terminal, while the ground terminal is connected to the ground terminal of our breadboard, the ground pin of our Arduino Uno. So after the proposed circuit assembly from our breadboard, this is our schematic for our circuit. So again, pins 1, 8, 9, and 16 are connected to the positive 5 volts terminal of our Arduino Uno. Next, pin 5, 4, 12, and 13 are connected to the ground. Pin 7, pin 2, pin 10, and pin 15 are connected to the pins used in our Arduino, which are pin 9, pin 8, pin 11, and pin 10 respectively. Next, pin 6 would be connected to coil number 2 of our step motor. Pin 3 would be connected to coil number 1 of our step motor. Pin 11 would be connected to coil number 3 of our stepper motor. And pin 14 would be connected to coil number 4 of our stepper motor. So that is it for our circuit schematic for this experiment. So I will first build the circuit and show the results afterwards. So yes. Alright, so now I have finished building our circuit. So now let us proceed with part 1 of our experiment, which is controlling the direction of our stepper motor. So first, I will show you that the serial monitor has appeared there. So if you would input A, the stepper motor is expected to rotate at a counterclockwise direction. There. At a clockwise direction, sorry. The stepper motor is now rotating at a clockwise direction. Next, I would input B. I will input B in our serial monitor. So the step motor is expected to rotate at a counterclockwise direction. So in reverse. Enter B. There. The stepper motor is now rotating at a counterclockwise direction. Next, I will input C in our serial monitor so that we would be able to stop the movement of our step motor. So stop. There. The step motor has stopped moving. So again, let us try. I will input A. Next, I will input B. Lastly, I will input C. Okay. So in order to prove, these are the received inputs of our serial monitor. So clockwise, counterclockwise, stop, and another set clockwise, counterclockwise, and stop. So next we would go to our second part, which is controlling the speed of our Arduino, of our step motor. So first we would upload. So after it is done uploading, let's go to our serial monitor. So it says here that you can now control the speed of your stepper motor. Note, for observable results, input with an interval of 100. So here. So first, I will input 100. So this rotation would take time. So for the meantime, I can show you the results from our serial monitor. It says that you've set the speed to 100. So for the next cycle, we would input 200. And wait for our stepper motor to finish its rotation. So now that it has completed one rotation, the Arduino has received the value 200, next 300. So it would be read later after one rotation. So now 300 is read by our serial monitor. So I will try to input 400 and wait for the step motor to finish one rotation. So now it has read 400. Next I will try 500. Next, I will try 600. Next, I will try 700. Next, I will try 800. Then 900. Then 1000. After that, let us move on to part 3 of our experiment, which is controlling the angular displacement of our step motor. So let us go to the Arduino Sketch and upload. So it is now done uploading. I'll go to the serial monitor here. First, I will input 50. Next, I will input 100. Next, I will input 200. Next, I will input 300, 400, 500. Next, I will input 600. I will input 700. Next, 800, 900, and lastly 1000. So as we can see from this part of our experiment, the higher the value that is inputted in our serial monitor, the longer is the angular displacement, or the higher the value is the angular displacement of our step motor. So here, so the number of steps entered is 50, next 100, next 200, 300, 400, 500, 600, 700, 800, 900, and 1000. So that is it for our experiment number 3. I hope you learned something, and I'll see you on the next vlog.